In the next 15 minutes or so, I'd like to tell you a story about how climate change is changing climate modeling. The story begins 15 years ago in the United States, where people were experiencing the second of a sequence of particularly hot summers. This is shown by the graph on the left, which plots the temperature anomaly for June over North America for the years between 1950 and 1988. You can see the two unusually warm summers there on the right of the graph. The senator from Colorado at the time was a man named Timothy E. Worth. He was a Democrat, Harvard-educated PhD, and had an interest in environmental and natural resource energy issues. He was familiar with the then obscure idea of global warming. He saw in the particularly warm summers an opportunity to make this obscure idea a bit more tangible for people, and organized a Senate hearing in which he invited this gentleman, James Hansen, to explain why he thought the past two summers had been so unusually warm. At the hearing, James Hansen announced he was 99% sure that this was a signal of global warming. And he said this was due to CO2, and it had profound implications for our planet and for people. The hearing had the desired effect. The next day on the New York Times, it was announced on the front page, global warming has begun. Of course, this caused quite a stir, as it had implications for many of the things that we took for granted. The leaders of the United States, Great Britain, and Germany at the time were all from conservative parties. In the United States, it was Ronald Reagan, Margaret Thatcher in Great Britain, Helmut Kohl in Germany. And you can imagine this isn't the sort of debate that they wanted to have on the front pages of the papers. So as all astute politicians, what they did was they referred the matter to committee. And the IPCC was born here on this two-page memorandum of understanding between the WMO and UNEP. The memo outlines three objectives for the IPCC. One is to make assessments of available scientific information on climate change. The other is to make assessments of environmental and socioeconomic impacts of climate change. And the third was to formulate strategies to meet these challenges. The assessments were prepared by scientists, or were to be prepared by scientists for governments, effectively bureaucratizing the process. And this had the desired effect of making matters a bit less tangible. So how have things turned out? Well, this was the situation in 1988. The graph on the left is the same as the one I showed before, but now I show global temperatures. I show every month, and I extend the time series back in time another 100 years until 1850. What you see is those warm summers in 1987 and 88 are still evident in the global record across the course of the year. In fact, the whole 1980s, which were dominated by two strong El Niños, show very warm temperatures compared to the rest of the record. At that time, we also had the ideas of Manabi, which is what Timothy Worth and James Hansen were familiar with. We also had ideas from this gentleman here, Klaus Hasselmann, who had been working out methods to formally attribute a warming signal to the increase of CO2. And it didn't take many years before a very bright postdoc of his applied the methods to the temperature record and showed that you could formally attribute the warming to the increase of CO2, maybe not to the 99% that Jim Hansen claimed, but at least to 95%. Well, if that wasn't enough, it didn't take long for the record to evolve as Hansen predicted it would, and the warming increased, and now there's very little doubt as to what its cause is and how it works. In fact, we understand it so well that we can write formulas for the underlying climate sensitivity, that means the sensitivity of surface temperatures to increases of CO2, here denoted by S. This formula only depends on basic parameters that can be measured in the laboratory, observations of the amount of clouds, and observations of how surface ice is changing, and a few assumptions about how clouds will change. And it ends up with a numerical value that's very close to what you would get from much, much more complicated models. The point being really is that we understand all these things, and this has been documented in report after report after report after report of the IPCC. We've documented that it's warming, that humans are responsible, that it matters, and that we know what to do about it. In retrospect, you could say the IPCC turned out to be a very effective way to build a social consensus around the answers to a few abstract questions. It was also very effective in developing a community of scientists equipped to deal with these sorts of problems. In the meantime, however, global warming has gone from being an abstract question of what if to a reality that we find every day. Many of you, when you see this date, will think of the coup in Chile in 1973 or the Twin Towers in the United States in 2001. But I'm referring to September 11th of 2023. It was on this day that this catastrophe happened. In the night or afternoon of September 10th, a Mediterranean storm came to the coast of Libya and dropped in the next 24 hours about 15 to 25 centimeters of rain over the coastal plain. Inland over the mountains, the rainfall totals approached 45 centimeters, according to measurements. This led a dam to break, which led another dam to break, which led to this deluge. Between 5 and 25,000 people are reported to have died. Now, you might wonder what this has to do with my story of global warming. Many people would say, well, there wasn't, the problem here was social dysfunction. We had forecasts, reasonably good forecasts of the storm, and reports had been written about the disrepair and dysfunction of the dam. So what's the problem? I would say that despite the reports and despite the forecasts, the problem was that people had an inability to really imagine in a tangible way what a storm like this could do. It's one thing to read a report, and it's another thing to see the implications of what's being reported. And I think for people here in Rwanda who've gone to the Genocide Memorial, that difference is very clear. So this inability to make things tangible is also leading to perhaps unnecessary speculation as we wonder how likely are large-scale DERNAs. Are we overreacting, being alarmist, or are we neglecting real risks? The answer, unfortunately, is we just don't know. On a much more practical level, now that climate change is here, it's not just an obscure idea that might be right. The question isn't what if, it's what's next. And so you see from paper after paper, from Senegal to Singapore, the questions people are asking are far from abstract. They want to know what to do. And even if they don't want to know what to do, sometimes they're being forced to ask that question. Here's the Task Force on Climate-Related Financial Disclosures, which is forcing firms or requiring firms who trade stocks on open markets to disclose their exposure to climate-related risks and perhaps their exposure to liability for the causes of those risks. So you see there's a pressing need for information now that climate change is here. So what's missing? Well, in DERNA we have reports, and for climate change we have reports, and the IPCC has been very successful in that regard. In the last 35 years, we've had close to 50 reports, filling about 30,000 pages. And not that it really matters very much, but weighing about 100 kilograms. So why isn't this enough? I think Timothy Wirth understood why it wasn't enough. And here you don't have to listen to me, but you can read this quote from Michael Oppenheimer from Princeton University. He was asked by Grist magazine in 2018, 30 years after the Hansen hearings, what he thought was the single biggest mistake over the past 30 years. And he said, "We never found a way to make the issue tangible to the average person." How can we make climate change tangible to ordinary people, businesses, communities, organizations? Here I use this metaphor of a woman looking out the window. It's a Dali at the Reina Sofia in Madrid. And I like it because it speaks to my imagination of the future. Maybe I like it because you're looking out the windows, you see the sea and the land and the clouds. But I don't see someone looking into the distance. I see somebody looking into the future, wondering what that could look like. Well, it turns out we have the ability to communicate what we know in many, many different ways other than reports. We're just not using it very well. Why don't we let the figurative people looking out the window imagine what the storms of their children might look like in the future? It doesn't have to be a visualization. This will appeal to some people. For instance, I'm a cloud scientist, so I like seeing pictures of clouds, and I can imagine that. But other people might visualize financial reports or crop losses or crop gains or river flows. In all different sectors of society, there will be different ways in which we want to make the information tangible. And in every one of those, technology probably has a role to play. There's probably no better example of the role technology has to play in changing our conception of the world than the Apollo program. One can't think of a more technologically advanced program than that. And this is a picture taken at the end of the Apollo program on the last crewed mission to the moon. Looking back, the astronauts took a picture of our Earth. And this picture has become one of the most famous pictures in the history of photography. It's called the Blue Marble. And many people credit it with changing not only how people perceive our Earth, but how we perceive ourselves. Now, something's interesting about this photo here. It was taken in 1972. At that time, we didn't have very much data about the atmosphere. We didn't have global coverage of satellites. We didn't really have any satellites effectively measuring the state of the atmosphere. But somehow we had enough measurements that if you use the basic understanding of the physical laws of nature, you could piece them together in a model of the Earth and come up with something that looked remarkably similar to what the astronauts observed. The beauty, of course, is that when you do this with the physics, you can look to places that the astronauts couldn't see. Here, watching the Earth rotate and looking at the emergence of the South American continent. You can also see the atmosphere in motion as you look at the storms race across the Southern Ocean there. You can look beneath the clouds and see the height of the ocean fields, the eddies, the flow through the Argulas Current region, its retroflexion, the salinity and the freshening from major river flows, the sea surface temperature under the clouds with the cool water over Namibia from upwelling, or the wind field with the fine scale structure stretched globally across the ocean. You can look at how the clouds and the wind interact. And you can zoom in to provide that image of the world, not just to Salvador Dali's woman looking out the window, but to children in Madagascar trying to imagine their future. This power of technology is what brought 150 people to Berlin in July to ask, can we use these technologies to help people understand and plan for the future? In 5 days of meetings, 3 of those quite intensive with workshops and discussions with social scientists, behavior psychologists, climate service providers, leaders from technology industries, and climate scientists, we developed a vision which we called Earth Virtualization Engines. And we envisioned these as an international collaboration to tap our technical capacity so that everyone knows how climate and climate change affects them. Everyone knows. And where this knowledge empowers them, everyone, to act. By generating sources of salient and tangible information, we believed we can catalyze a change in the broader ecosystem of data and services to help deliver a just, equitable, and scientifically grounded basis for action. Now, the vision for EVE is still developing. That was the first real articulation. And I'm here in Kigali to invite others to join this effort to help us shape EVE's vision in a way that reflects all of our values. This evening we'll have a town hall where many people can join at 8 p.m. And so I hope to see many of you there. Now I want to add here that EVE's vision is grounded in real things. It's not just a pie in the sky statement or reflection of our values. It really reflects our understanding of new capabilities. And these new capabilities are HPC, high performance computing, as now the ability to provide the magic needed to deliver data at scale, the scales where people live and feel and experience. and to do this globally. Using the Apollo analogy, you can think of this as our rocket. AI can provide the magic needed to allow people to interact with the data that we produce from our rocket, to look into the future. This is our lander. And this practice of international cooperation, which we've developed over 35 years of IPCC and coordinated activities, can now be consummated in real international cooperations that can bring this all together. Our headquarters. What we need is an Apollo mission to tap these potentials. And here, the World Climate Research Program has an essential role to play. For one, the rockets. To build these, we need the expertise of people in the room here in Kigali today. We need to be able to solve the problems that the fine-scale modeling doesn't solve for us for free. How does small-scale turbulence interact with the flow? What happens in the land surface? How does the land biosphere interact on scales that are resolved so finely? How do we represent air-sea coupling at such fine scales? Do the waves matter? How about mixing at the base of the ocean mix layer? And of course, there's all the complexities of the cryosphere, ecological systems, and so on. So it will be a task to build the best rockets, but we have the communities in place. Even when we have them, the question is, how do we use them efficiently? How many do we need? What scenarios should they fly? How should we judge their uncertainty? These are all sorts of questions we have enormous expertise here to help answer. What about the landers? Well, this is an area of enormous growth, but one of the things we realize is we need to tap our technical and infrastructure abilities to lay out data in a way that people can access and learn and use. We don't want to build giant distributive data sets. We want to build AI factories where people can go to the data and use their expertise to develop tools for their customers, for their communities, for their users, for their stakeholders, to help them envision what the rockets are, where the rockets have brought them. And of course, we need the mission control. And here we need international cooperation. We need to do this in ways that empower existing efforts, being cognizant of the role of very different communities and the different ways in which they interact with information and bring new information and experiences to the table. And to do this, we also need to substantially increase opportunities and training to engage underdeveloped talent. Building the capacity to engage civil society in exploring possible futures will reduce vulnerability. And by making changes tangible, it will also strengthen the social consensus needed for mitigation. So here I'm at the end of my story in 2023 to say a climate ago we didn't have the tools we needed to make climate change tangible. In that respect, this 35-year detour into report writing has been quite helpful as we've developed these tools. And now things are in place so that if we work together, by the end of the decade, we could make climate change much more tangible for people in ways that would help them answer the questions that climate change is bringing. But to do so will require our own Apollo program. So why not take this next step here in Kigali and think about how to build Eve's first node with and for Africa. Thank you.